He's one of the two people behind Astronomy Picture of the Day, also known as APOD, and he's here to tell us all about it. So.
Okay. Screen so I can actually see it here. So today is going to be two talks in one, same price, which is nothing. I'll be alternating images of the best images of our universe, in my opinion, particularly those from the past year, with this strange and tortured history of the Astronomy Picture of the Day. So I am this person, Nemiroff. I am at Michigan Technological University. So I will give a 2-second plug, which is a smaller high-tech university in the Upper Peninsula of Michigan. It's primarily engineering and science, and surprisingly good because I didn't know it when I went there. I didn't even hear of it before I went there. But there's a lot of, it's a pretty geeky campus actually. It's sort of the second geekiest campus after Caltech. But it's a lot of fun, and it's a light teaching load, and there. So that's the advertisement. So this is the abstract, so you can't read that all now, so you should have read that already, so now you can feel that. Here's the bio, you should have read that too. All right, here we go. So, I'll start with a little history of APOD. I think it was 1993. And so there was rumor about that there was this new program called Mosaic. Is anyone old enough to know what Mosaic is? Informed audience. So Mosaic was first, it sounded like a waste of time. It sounded like a program I didn't need, I had enough to do, didn't want to hear more about Mosaic. But people kept saying it was pretty cool, and I didn't understand what Mosaic was. So I went there, and I looked around, and I still didn't completely understand what all the hullabaloo was about. But I did find, to my delight, that it was an MST3K site. Who knows what MST3K is? Mystery Science 3000, and it was Joel Hodgkin was on actually, so it was really cool. And then I began to understand the power of Mosaic. Okay, so this is the best space images of all time. Yes, it is quite subjective, so I chose these. I'm guilty, and your favorite space image, if it was included, I apologize already. Okay, so I'll jump to this one. This is a, you might recognize it. This is the Earth, and this is voted, I think, or described by Time magazine as a picture of the century, or the last century. This was taken by the Apollo 8 spacecraft as it came around the limb of the moon in the 1970s. And here you see the big blue marble, which is the Earth. So everyone you've ever known has lived there. Everyone you know now lives there. And that's sometimes called the big blue marble. It was one of our early images back. So here's the name that we gave it. Here's the credit as best I could do, and here's when it appeared. So APOD stands for Astronomy Picture of the Day, of course, 1995. This was posted on December 25th, 1995. So if you want to know more about this image, you just go to that APOD page. So how do you find APOD?
When did you start? When was the first picture of the day?
Okay, that was on June. First picture, that should I repeat that? Can people hear your question, or should I repeat it?
They can hear
it. Okay, so June 16. I got a bit of a history in here. June 16, 1995 was our first image, and so I will get in. If I skip over more of the history, tell me, and I'll go back and do it. So first, some even prior history to that. So Jerry Bennell and I had a really great boss, Jay Norris, and so we had a research group at NASA Goddard Space Flight Center. We were researching, in particular, gamma ray bursts, which are some of the most powerful explosions in the universe, and so we were happily doing that. But Jay was, Jay's a relatively young guy, but he's interested in retiring, and he wanted a retirement ranch. So he bought land. I believe it's in Idaho. He might have first bought land in Colorado, but it's in Idaho now. And so he would go away and build his ranch for like a month at a time, usually in the summer, but not always. And then he would come back with pictures of this sloping land that had brush on it, and he was ordering logs and stuff like that. So he was building his retirement home from the scratch year by year. It was a really interesting project. I haven't done so myself, but when he was away, we were sitting around at NASA Goddard Space Flight Center with relatively powerful computers. Now, NASA Goddard is a big place. Some people might think Google is people sitting around in just a small office complex, but actually it's a campus. So NASA has many campuses, as you know. NASA Ames is right here. NASA Goddard is a big, big campus. You know, more than 30 buildings. And so we're sitting in, one small part of one building, but still, we had relatively powerful computers there. We had DEC alphas. Ooh. We had what was considered to be an unbelievable connection to the internet. You did not have to dial a phone and take the phone and put it in there and hear doo doo. We didn't have that. It was, I guess, several T1 lines, and it was essentially instant internet, so far as we can tell. And we didn't even know that existed anywhere else. Before that, back in 1994, so I'm going to digress, we were more interested in the computers that were sitting on our desks, so we decided to compute digits of irrational numbers, just for fun. So the reason for that is because we get in, Jerry Bonnell, my office mate, and I, who created APOD, together have some very strange office conversations, and one is that, is there an encyclopedia of all the information in the universe? And so why would there be? Well, let's say you go into a library and you say the first book on the first shelf, you give that the letter, if it's A01, or give it ASCII codes, and then you make that book into one long ASCII code. Then you take the next book and you make that a long ASCII code. You just put it right next to it. So you have these long streams of digits. So then you take the entire library and you have this really, really long stream of digits. Now you look at that and you say, no, that's obviously not the most compact stream of digits. This is an inefficient way to have all the information in the library. So you can say, well, I'm going to start, if there's lots of spaces in a row, I'm going to make this shortcut. We're only using letters, the numbers from 1 to 26, so we're going to make better use of there's any number of ways. Ultimately, when you get to ultimate data compactification, it looks to people like it's just random. So to the uninformed eye, totally random digits look the same as all the information in the universe digits. So where do you find a long stream of digits? So we decided that pi had a long stream of digits, and we were going to look at the digits of pi and see if it's an Encyclopedica Universica. So we started looking at that and seeing if there's obvious repetitions and non-randomness. Another debate between us two is what's the best random number generator? Because obviously the random number generators you're running into are just obviously poor. Wouldn't it be cool if we found the digits of pi that had non-random? Yeah, so there was a win-win-win situation in the sense that either we found non-randomness, and that would be cool because pi had some non-randomness, or we found that it was completely random, and we'd be able to use them as random numbers, or we found some way to find a key so we would be able to decode all the information in the universe. So we then found out that it was unusually hard to compute the digits of pi, and there were the Chodnovsky brothers in Columbia who already did it, and they were making vague illusions that there were already patterns in there, but we decided that the arctangent functions were too difficult to generate lots of digits, but E was a lot easier. So also the square root of numbers, single integer numbers, is a lot easier to just stream out those digits. And so I started streaming out the digits, and Jerry started checking them, and to our almost surprise, we set the record for the square root of 2 and the number E, within a few months. So we did E to 10 million digits, and I later found out that we beat the record by S. Wozniak on his Apple computers. So we never found any non-randomness, so we don't know what all the information is in the universe, unfortunately, is right now. Then Jay came back and showed us pictures of his ranch. Okay, so this is a picture of the moon, jumping now to the other part of the talk. The Apollo astronauts landed on the moon several times, starting in 1969. The last lunar mission was Apollo 17, and the moon has been called a magnificent desolation. It's not really colorful. It's not like the Google logo with all these colors. It's quite bland. It's sort of brownish gray, but somehow, even in those colors, it's obviously alien and it's somehow magnificent. And it was called that by several of the astronauts. So here you see astronaut Harrison Schmitt with the lunar rover on the last mission to the moon. human mission to the moon. And he's doing something. You can get an idea for the majesty of the mountains and so forth. Okay, so Jay was going to go away again and build his ranch, so that was cool. So Jerry and I continued our bizarre speculative discussions, and we decided that we were thinking of ways we could, things we could do with this great connection to the web that allowed us to see the MST3K site, for instance, practically instantly. So we decided that one thing we could do is we could designate popular websites as they were coming on. We could say, well, this is a gold site, like Records. It's so popular, you get a gold designation. Or this is a silver site, or a platinum site. So then we decided that we're not really well connected enough to that. We don't, why would people believe what we say? How would we know that they went gold other than thinking, gee, that seems to be popular? We just weren't connected, and we're too ignorant of the way the web worked to really go that way. Another idea said, well, we know a lot about astronomy because we're astronomers. What about if we answer astronomy questions? People could send them in, want astronomy questions, so we decided it's just too hard. So we wanted something easier because we were inherently lazy. Okay. This is our sun. Our sun is unusually constant star. This is a picture taken from the SOHO observatory that orbits the Earth and continually monitors the sun. You can see its latest images as they come in every few minutes. This is a huge, there's a lot about the sun that isn't known. The sun is unusually stable because if it wasn't so stable, it would be very hard for life to develop on Earth. Even though it's stable, it's constant, cauldron bubbling of heat. It's not on fire. There's not a lot of rapid acquisition of oxygen going on, but it's constantly throwing off prominences and stuff like that, like this. And so here you see there's the active area there, the prominence, the Earth could easily fit inside this seeming claw. And so one of the great advances in modern technology has allowed us to monitor the sun and try to understand the sun. So who cares if you understand the sun, so long as it's constant and it comes up tomorrow, we're good. But then again, if the sun is now coming into a period of solar maximum, and they're worried that there could be solar flares a lot more powerful than the one you're seeing there, that could knock out communication satellites and even cause power grids to go down. Also, astronauts in orbit get splashed with radiation, and that's not fun. So there's good reasons to try to understand the sun. Okay, about this time in 1995, going back to the historic part, everybody was, including Jerry and me, was receiving email attachments that said, look at this cool image, isn't this cool? What it appeared to us was happening was that although there were press releases, there seemed to be a lot of images that were going around the web unexplained. And we found that annoying. Wouldn't it be a better web if when you found images, they came with an explanation, written by someone who might know something about it? So we didn't know everything about all the astronomy images, but we're professional astronomers. We know some about it, and we could research them and make. So one of the motivations is let's not let the web grow up ignorant. Let's make the web into a better place where things are explained. Also, another motivation for this is that I had a graduate student friend when I was in graduate school at the University of Pennsylvania in the 1980s, and he had his own slide collection. So when people would go off and teach astronomy classes, many times you would want to show in your Kodak slide projector, you would get these circular carousels and you'd put them on there and it would click and the first one would then get stuck and you'd have to stick something in there or something to get it out, but eventually you'd get it working after half the class was over. And you would see these images of whatever was a topic or background images of the Earth, the planets, things like that. Well, there kept being new images, and my friend, Jeff Goldstein, in the next office, had the best slide collection. He would spend time creating this great slide collection. So after a while, even the professors at Penn would have to go up to him promptly and say, Jeff, you have that really great slide on Saturn and stuff. Can I just borrow that for my class? And he would take a little bit of a show. He'd go and he'd pull it down. He'd say, this one, oh, sure, you can have it. But wouldn't it be great if we didn't have to grovel to people to find the best images? They were just more or less online. So that was another of the underlying thought that went into APOD. Okay, another of the greatest images of all time. This is the pillars, sometimes called the pillars of creation. So stars are being formed in the Eagle Nebula. So you can't sit there and watch a star being formed. It just happens way too slow. You might be able to watch a star explode in a supernova or a nova, but here the reddish stuff are stars. So you can look in the pillars, particularly at the end. So the stars actually destroy the pillars as they're formed, but things happen on a very slow time scale, millions of years. Although they do destroy them by usually the wind, the light from the stars, the very massive stars is so energetic, it's in the ultraviolet range many times, and it just rips apart the dust and the molecules there. And the wind pushes it out, and then explosions from them can actually rip these things apart. So our sun was probably born in something like this. But these things dissipate, and eventually the stars that are formed have no clear memory of it. We have to infer it. Okay, so back in June 16, well, after some discussions is how we can what we'll do. Jerry and I started APOD, so. I guess it sort of started as discussions one time in our office and also at lunch. So on June 16, I posted the first one, and then on June 17, there is not one. And there's not one on June 18. Because you're busy, you're doing stuff. You got your projects, you got your research, you got stuff to do. This is additional, superfluous, not mandated. But Jerry and I would talk, and we would have lunch together. And after several lunch discussions, it still seemed like a good idea. So many times, particularly with me, good ideas that sound good one day, put something up the next day, not as good. Sometimes, what was I thinking? But this one continued to seem like a good idea several days later. So we kept it going, and I think the first day of continuous going was the 20th or 21st, and so it's been going every day since June 21st, 1995, which raises the question, is it one of the longest running blogs? To which many people who follow APOD say it's not a blog. Stop that. I don't consider this a blog. They think a blog is something where people talk about what happened to them yesterday or something in the news. And it's very personal. So some people might consider that the APOD is really not about us at all. We don't mention ourselves. So we've been going. So some people, though, do consider it a blog because the concept of blog, which was coined after we started, has undergone revisions in several ways. So some people do. Every now and then on our associated site, discussion site, the Asterisk, well, we once had a vote, and I think non-blog beat blog in it, but it was close. That was about 2 years ago. Maybe we can rerun that. So the site also looks pretty much the same today as it did back in 1995. All this new technology to create web pages and stuff like that has come out, but we have availed ourselves of almost none of it. So it's a little bit like the Volkswagen. So the Volkswagens look the same, but it still gets you there. So what we're interested in is the image. Everything else is somewhat secondary. It doesn't have to be fancy. We frequently get email from people who say they want to spruce up our site for free. We'll give you a dark background. We'll make it, you can slide your finger or whatever. But we don't care. What we do, though, back in 95, you couldn't center things. The center command didn't exist in HTML. But when that came out, we made use of that one. So we now center things. This is the nearest galaxy to our Milky Way galaxy. Our Milky Way looks a little bit like this. This is the Andromeda galaxy. So this was taken not by a professional astronomer, but by a physician. Currently, amateur astronomy has undergone an explosion due to the ability of, for instance, charged coupled devices, CCDs and CMOS devices, to become relatively inexpensive and be hooked up with relatively large telescopes. And so now an amateur who has a little bit of money on the order of a few $1,000s can take images that couldn't have been done when APOD started. So this is just one of the most spectacular images, and this is actually really wide for a professional telescope. Most professional telescopes see relatively small fields of view. The Andromeda galaxy is a relatively wide field of view, and but with amateur telescopes, they can just sit on this with their modern CCDs and let the data come in, and eventually you get a really fantastic image. So this is the Andromeda Galaxy.
How wide in degrees?
It's about a degree or so. Depends how far out you want to go. I'm not really great with numbers. Some numbers I am, but many numbers I'll embarrassingly won't know. But I think it's about a degree on the sky. So the moon, the full moon's about half a degree. I remember. Okay, so the first day we did APOD, we had 14 page views, and I don't know how they found us. One of the most frequent questions we used to get was, won't you run out of images? People were concerned for us. You're just going to run out, and you just have to keep running the same one or something. So even when we started it, we knew that the Ranger series of NASA's Ranger program, which crashed things into the moon, got hundreds of thousands of images of the lunar surface, hundreds of thousands. So we didn't have to repeat it. We just have the next lunar crater image. Here you see another crater, which is gray also, but looks slightly different. So we weren't in danger of repeating. We could keep doing that. But there were lots of images out there, and so we were estimating how many. We weren't really worried about this. So there's more danger that APOD could become a little bit boring with less diversity than it would run out of images. So we were keen to make, back in '95, there was a list of new pages that would come on the web. And people would go there and see what's coming on now. What major organizations might have a web page now. So once we were announced on that, and we were really keen to do that, our page views went up into the hundreds per day. So also back then, people had ideas similar to our gold and silver idea, and one group called themselves point communications. I don't know what happened to them. They're not the same as the point communications around today. They were designating sites top 5% of the web. Who remembers that? Anyone ever see the top 5% picture? So we were lucky enough to be designated top 5%. We were very proud of that at the time. Now you don't really see that so much. Okay, this is one of the greatest images of all time. Again, this is looking back on an eclipsed Earth. This is not taken from our current space station. This is taken from the now defunct Mir space station. And what you're seeing, the black thing, is actually a total eclipse, looking down on it. So a total eclipse is a shadow. So if you're standing in the middle of this shadow, looking out, you're seeing the moon completely blocking the sun. You're in the moon's shadow. If you're on the edge here, then you see the moon blocking part of the sun. So when I teach class, I like to bring this up because it really helps people visualize what an eclipse is. It seems less magical when you show them from this angle. This is going to zip across the Earth really quickly, and if you're lucky, you can see maybe a couple minutes of totality. It's sort of a game people, particularly rich people, try to travel around the globe and try to see a total eclipse of the sun. And you can lose in that game as well because you can be clouded out if you're unlucky. Okay. Thank you. Okay, so Jerry and I have been going since we're past our 16th year anniversary. After we started in '95, we decided to ask NASA what kind of regulations would apply to our website, and they told us that that's not the people in the administration of NASA, NASA Goddard Space Flight Center, told us that that's not something they can tell us because the World Wide Web is for scientists and is generally unregulated, so they don't have policy. So we go, great. So we just kept going. Now they have a lot of policy, and sometimes they try to apply it to us, and eventually we're going to have to. But we liked our old-fashioned look. We consider that we're sort of grandfathered into our look. But we might have to go back on that at some point. So here's another of the greatest images of all time. This is, people think this is an image from the space shuttle or the space station, but that can't be because it's always night and it's only night on half the Earth at one time. So this is taken by the DMSP satellites, Defense Meteorological SP satellites, and they take pictures of the Earth pretty much a lot of the time, and they can digitally stitch together those images where there were no clouds and it was night. And then you put them together and you can see that there are people here for instance. And people generally turn on their lights at night, so you can fool them if you keep turning your lights off. But it's interesting because it gives people a perspective as to where they live on Earth and what's populated and what's not. This was an email attachment phenomenon, and actually it was really good advertising for APOD once we realized how many people were attaching this to emails to put out an image that actually told them about our website, and so that was our best advertising mechanism, just attaching our address and name to this email attachment phenomenon. That people would say, oh, look at this, because almost no matter where you are in the world, you're looking to see whether you're lit up on that image. So you can see the eastern seaboard of the United States, the western seaboard of Western Europe's pretty good, Japan's lit up. There are places that are not lit up. So if you go to the Amazon, for instance, you're not seeing lots of people or lights. Sahara Desert, not lots of people there, and the outback of Australia is kind of empty as well. So we haven't saturated places to live on the Earth. Okay, so we would have to research some of the images. If it came out with a press release, that was good, but we pretty much, all the words on APOD come from Jerry or me, Jerry Beno or me. So first we tried to, the reigning search engine at first was Veronica. Does anyone remember Veronica? I guess it's everyone, I think everybody here would know that one, because it's a search audience. So then people said, we got to try web crawler. So web crawler was indeed a big improvement over that. Site, Yahoo was good. Yahoo was, when it first came out, was their strong thing is that they were done by people. That was their mechanism. People were going to create the lists, and so you don't have to worry about the machines. Alta Vista. I remember when Alta Vista came out, I was very, very impressed. And I proudly proclaimed to Jerry and whoever else would listen that is the ultimate search engine. It has pluses, it has minuses. It's just great. I don't see how it can be improved. So we've reached the limit of search. I told you, this is it. So I guess so obviously when Google came out, once again, I was wrong about something, most things. Google is obviously what we use the most. So now I'm going to jump to the current age of images for the best images of 2011. Oops, that was unexpected. Okay. So this is there are lunar eclipses most years. My notes, see, notes. So this lunar eclipse was caught from Austria. So we get images from all over the world. So here you see the sun rising in eclipse with the moon knocking out part of it. So it's a partial solar eclipse. This is an impressive tower in Austria. So today, APOD has evolved. It is now arguably one of NASA's most popular sites, the most popular. People voluntarily translate APOD into most major languages. So we get email from somebody saying that I'm from, some country. Can I? Yeah. And so we allow them to do it so long as they don't violate the image copyright problem. So that some people mistakenly assume that all the images we run are public domain images because we come from a NASA.gov domain. That's not true. Some are images in NASA.gov, but some are owned by the copyright owners. So to use those in a commercial setting, we believe we don't have the right to give that permission. You need the copyright owner's permission to do that. So still, if they are relatively true translation of APOD and they don't have commercial advertising, we allow them to do it. So we now are in most major languages, so I guess this would impress many groups other than the Google group that every major university domain accesses APOD every day, as far as we can tell, and that in June 2011, APOD made the front page of Data 25 times.
You said most popular. Do you have any traffic statistics?
Well, we only keep log files, or log files are kept for us of what APOD is doing. But every now and then there's some email that goes around that we're copied on that shows what different, like NASA got its Space Flight Center, what percentage of we are from that. And from that we can estimate that we're doing pretty well. Also, no other page from NASA makes the front page as big as often as we do. Not that big is the ultimate in determining popularity, but it's one indication. Okay, so this year, well, this was first seen last year. Saturn is doing something unusual. there's an unusual storm that is developed, was first seen, I think, in December of last year. And there's the Cassini mission that we have currently orbiting Saturn is taking pictures of it. You can see this from the ground. This was discovered by amateurs with their great equipment and is constantly being tracked. So this storm now is a belt that goes around the whole planet of Saturn. So it's interesting. We wasn't expected. How storm systems develop and evolve is important for understanding Saturn and its winds, as well as hurricanes and things like that on Earth. There's no similar thing as a hurricane on Earth. Okay, so I'm going to do so another things going on in modern astronomy. Astronomy changes very quickly. So if you teach, for instance, calculus, it's pretty much the same every year. However, if you teach astronomy, like I do many times, you constantly have to update what's going on. So this is an indication of what's happened just in this past year that is not in published textbooks, because textbooks don't have a turnaround this quickly. So we have the Kepler satellite that started taking data in 2009 that orbits the Earth, and Kepler looks at a small part of the sky, it's like 1/400th of the sky, and looks for sun-type stars and looks for eclipses of sun-type, or like you saw the moon going in front of the sun a little bit ago. If a planet goes in front of a star, it becomes slightly dimmer. And Kepler is so sensitive that it can see that slight dimming. So you know how big it was, you know how long it takes to go across, and from that you can determine that there are other planetary systems. So one of the forefronts of research astronomy is discovering what else is out there in the universe, discovering other planets in the universe, discovering whether those planets have any life on them. Hopefully we can find someone we can talk to one day. But right now we're in the stage where we're just finding planets. So Kepler has the most sophisticated system known. There is I think it's a 6-planet system now. And so here's our solar system down here for comparison. The central star is roughly the same. These planets, although tend to be bigger than we see in our solar system, here's Mercury, for example, and most of them are inside the orbit of Mercury. One of the problems is that in order to find things in the order of the Earth, it takes longer. See, Mercury zips around the sun so fast that you can see it go in front, and you can verify what's going on the time scale of, months. But something with the Earth, you need years it's going to take years to go around the star to verify what's going on and be sure. So as time goes on, Kepler hopefully will be able to see more and more distant worlds, eclipses. Okay, who is APOD's audience? So APOD is designed to be a resource for students. In particular, a lot of, we get, as at every university domain, we have a lot of teachers who use this with their class because they know that astronomy is not like calculus and they like to keep things up to date. And also, a lot of astronomy stories are in the news, and sometimes the news people get them right, and sometimes they don't get them so right. However, since we're professional astronomers, our descriptions of it are usually better, and we have a lot of links, and we have no advertising, so it's something that many teachers prefer. And so many professors, teachers in high school, they will use our site, and so students know it. So we consider that to be sort of a base that hopefully will continue on for years to come. As long as we can remain relevant to teachers and students, then there will be lots of students learning about our site, and many of them continuing on even after they finish their class. Our biggest group is sky enthusiasts, just people who are just interested in the sky. Many of them, I used to say many of them are professionals with computers on their desks, but computers are so prevalent nowadays that everyone's got them. They've got computers in their pockets. That's our biggest group. But they'll leave us in a minute, we know that. But still, they're our biggest group. Professional astronomers, surprisingly, just about every professional astronomer has heard of APOD and has seen it on times. Either they're teaching, or they need some images, or they just want to stay up. We do have relatively quick, sometimes a quick turnaround cycle. As I was saying, many of our images are written beforehand, a few days beforehand, as the images come in. But many times sometimes we'll go in the night before if there's a very newsworthy item, and we will report on the item, and we will give our opinion as to although we don't say it's our opinion really, that it's useful and interesting. So one example I gave is when the Cassini-Huygens orbiter landed on Titan. We were sure to get that in the very next day because that was a big news item. So whatever was planned for the next day was just pushed off into the future, and we wrote up something right then. Okay, so in modern times, we now can monitor the sun in better detail than ever before. Not only that, but we can see the back of the sun. There are actually clever ways of looking at the front of the sun and finding out what's on the back of the sun, but this is a more direct way. There's two satellites out there now called stereo satellites, and they are drifting around the sun. So if you picture, let's say the center, this is the sun and the Earth is at the bottom. The stereo satellites are essentially drifting as the Earth goes around the sun and have now reached a point where they're on either side so they can see the entire sun. So now if a flare occurs, if there's some kind of active region, since we're coming into solar maximum where there's lots of activity on the sun, we're going to be well situated to see these things happen no matter where it happens on the sun. Now even as these two satellites go behind the sun, there's still the third part, the Earth part. So we still have satellites around the Earth, and we have actually ground-based solar observatories that see what's going on. So just this past year, we've developed the capability to monitor the entire sun. So that's something that's new. 2011, new era. Okay, this is a supernova that was probably seen 40,000 years ago. It is one of the images that's sent to us. This is an amateur astronomer, and they do best with the wide images because the professional telescopes don't do wide so well. And you can see that a supernova explosion is tremendously detailed, and this one has left a spinning neutron star in the center. So one of the things the amateurs can do is they can what's called burn the field. They can go very deep, and they can see many more of the filaments and textures that weren't so visible before. It actually helps science.
What do you mean by burn the field?
They can just sit on it. Their telescope can just sit on that part of the sky.
Oh, for multiple days?
Yeah, well, it can be for multiple days. Yeah, and they can just keep building up an image. Whereas a professional observatory would never have the time to do that. And what you do is you pick up some things that people didn't know were there.
So they substitute time for mirror size?
Yes. A big bucket, a big light bucket, a big mirror ultimately gives you it's like making your eye really big. It gives you the chance to see deep relatively quickly. But if you can stabilize and look long enough, you can take a smaller telescope and eventually collect the same number of photons. Okay, so every day we do a new one, although that's not completely true, where people are sometimes surprised to find ones that have been repeated. In particular, we used to do both Saturday and Sunday, but now Jerry seems to be putting new ones in on Saturday. That's his repeat day. I typically do Sunday, Monday, Tuesday. Jerry typically does Thursday, Friday, Saturday, and we exchange email to see who's the least busy who gets to do Wednesday. So I almost always, though, I will do a rerun on Sunday. Now, am I cheating? Well, maybe a little bit, but many people haven't seen some of the best astronomy images of all time. At any one time, the most readers we have are new. So going a couple of years back into the archive and saying, here's something, well, that shows a great image that has been overlooked by much of our audience. Also, we can show it in a larger format because we've gone to larger and larger image formats as time has gone by, so we can probably put on a larger image in better detail. And we can also update the text if anything new has happened and update the links, because a lot of links go dead as time goes on. So we can refresh it. So I actually think it has some utility. So on the upper right of all the APOD pages, we say written by a professional astronomer, which Jerry thinks we should delete, but I think is an indication of a good housekeeping sign of approval for people who don't know what to believe. So knowing that we are professionals in the field and that we're perhaps less easily fooled than some might be of use. So what software do we use to create the HTML? Typically, it's VI, which is an editor on Linux. So we just take the old one and we load it up and we hit the backspace command and we delete things that were from an old APOD and we type in the new stuff. And it's like filling out a form, really. The APOD hypertext is so uncomplicated that it's just easiest to do it that way. We're not doing anything fancy. We do use the center command, as I said. So actually, Jerry does most of his on VI. I actually just use any generic word processor I can find, and then I upload it, and when I find my mistakes, then I go into VI and change those mistakes. Okay, so our hypertext is what we call best link, what I used to call full web hypertext. The idea is to explain things. When you writing in hypertext can be different than just writing text, because you can link to stuff. So if I say redshift, if I'm just writing in text, I'm going to feel pressure to explain what redshift is to the audience. But if I'm writing in hypertext, I'm not feeling that pressure because I know I'm going to link it to a description of what redshift is, and people can just click it. So what that allows our texts to be is more succinct and compact, which is good because it really gives just a paragraph on what, and if you're interested, you go, if you know stuff, if you're interested, you can just read that paragraph and then you're gone. So most people don't read the paragraphs, they just look at the picture. The next people read the first line, and we try to draw them in. But if you read it, then you can go to almost arbitrary depth because you can start following the links. It can explain things, it can give you background, it can say that we didn't just make this up, look at this, this is from the press release or something else, so we're not just making this up. So a while ago in the late 1990s, Fox News was one of the people who had their own sort of mirror. They would get permission to run the copyrighted images. And so I went to visit them once. And one person told me that they didn't they don't use full web hypertext because if someone follows a link outside your website, you don't know they're coming back. So they were concerned that we're losing people. But that's not our philosophy. Our philosophy is we want the most informative description with the most informative, and if they go away and come back, well, don't come back, well, okay. But we just want, each one is a little bit of a work of art in a sense, and we want the best links possible. So here's the best link we know to explain this. Although sometimes we'll go for diversity if we just keep hitting on the same link. Also, by strange coincidence, that's probably helping us with Google ranking. Yeah. Okay. Okay, so people are drilling holes in the bottom of the world for astronomical purposes. They're looking for among other things, neutrinos. So they melt these holes, actually. They're melters. And they go down several football fields, and they put basketball-sized light detectors in it. And here you see one being lowered down. And the idea is that if there's a fast neutrino coming by, it's going to hit something and it's going to cause blue light, Cherenkov radiation. It will then be seen by these optical detectors, and then you would know that there are neutrinos going by. So if you look at the universe, every way you look at it, you see a different universe. If you look at it in visible light, you see stars. If you look at it in ultraviolet light, you see something different. If you look at it in X-ray light, you see something completely different. And it just all tells you about our universe. Well, if you look at it in neutrinos, you're going to see something completely different again. So one thing is people thought they would see a really bright sun, but it turns out the sun isn't anywhere near as bright as they thought it would be in neutrinos. And that helped us understand about neutrinos and the standard model of fundamental physics. So now we're hoping that things like the ice cube collaboration, which is melting holes in Antarctic ice, we'll be able to see out further than the sun. It has seen the sun, and hopefully we'll be able to see neutrinos from explosions like supernovae and gamma ray bursts. And there's even hopes that it could test exotic physical concepts, such as unseen spatial dimensions and faster than light travel. But I think the most conservative hope is for supernovae neutrinos.
And they do it there because the ice is clear enough?
Yes. It's very clear ice down there. Yeah, doesn't really have it. So in Antarctica, that's one of the best places to find meteorites too. So you can go on an expedition to Antarctica where you can get on a snowmobile. You can sign up for this, and you go skating across the blue ice on your snowmobile, looking for any change in the blue ice you can find, because any rock that landed there probably came from space. And so they have rows of snowmobilers going across. Oh, there's one from the collector and finding meteorites. Okay, so this past year was the first time that a satellite visited an asteroid, a comet, twice. So this is the Stardust Next spacecraft, which went by this past year. Now in 2005, another spacecraft went by, and it dropped an impactor, I think around here. And impactor, we're trying to find out how dense this is. Is this a rubble pile or just loosely held together? Is it like our moon? What's it like? So what chemicals are there also? So they're looking now, they passed by to see if they can see differences from when the impactor struck here and raised the plume. And they're seeing, I think, some differences, but there's a lot of work to be done. But the notable thing is we're now actually returning to comets and seeing not only how the impactor changed it, but when this thing went past the sun, it changed its appearance. How radically do things change their appearance as they go by the sun? This is our International Space Station, continually growing. So you can see wide solar panels. There are a number of astronauts that are there pretty much all the time. So we live in the era of a growing International Space Station, the ISS, and even 10 years ago we didn't have such a presence in space. It's continually being built. It was visited by the space shuttle before. I believe the space shuttle is going there again starting tomorrow.
How was this picture taken?
This picture was taken from the space shuttle. Almost all of them are, but I have one that's not. Okay, so APOD rejects about 10 to 1 images right now. The images are chosen. Okay, we know our audience, we think. They're chosen mostly, the most important thing is historical importance. If there is a historically important image coming up, some spacecraft landed somewhere, some new image of the sky from something, then it needs to be run as part of the historical archive of what we know as a species. So even if it's fuzzy and Technicolor blob, not visually spectacular, we're running it. After that, you can usually tell in a second or two, like, oh, that's a really cool image. If it's not too photoshopped up, then we'll probably run it. If it has high news value, it helps. If it has high educational value, that helps as well. Okay, I'm going to start going a little faster. So this is the microwave background. So in the microwave background, this is from the very early universe seen by satellites that orbit the Earth. This is taken from the Wilkinson Microwave Anisotropy Probe WMAP. And we can tell a lot about the universe from the different ways that spots have appeared on the microwave background. These photons come to us from just a few 100,000 years after the Big Bang. They pretty much understand why you would get these patterns, which tell us the universe is 13.7 billion years old, but here's a spot that's circled that was causing some consternation. It doesn't look as impressive as the other spot near the center, but it is deeper, and it's been called the CMB cold spot. So a lot of effort has gone into trying to understand why that is, and sadly the current best guess is that it's just a statistical anomaly, and that there's no big discovery there to be made. Here's Kepler, all the getting lots and lots of stars. Here you can see the relative colors of the stars, and the little dots are in front of them are planets, so you can see there's hundreds, thousands of these things. Here you can see the one that's all by itself is what our sun would look like if there was Jupiter and Earth in front of it. And so this black dot you see is actually Jupiter, you can't see the Earth. So this year we humanity put a spacecraft in orbit around Mercury. And this is a picture of a key, interesting crater on Mercury, which looks somewhat like the moon. And so Messenger will be taking many images for years to come, and I'm going to speed up a little bit. Okay, so let's see, image selection. So we're saying, as I said, 10 to 1 images, most of them are rejected. The program I typically use to look at images is something called ImageReady, which is, I bought it in 1998, and I just don't have a reason to change. It's by Adobe also. What I like about it is that you can you can just hit one button and compare images from, so we reduce the image sizes, but if you can't tell the difference, then what does it matter? So the image that appears on the APOD front page is sometimes the lowest in terms of bytes, that looks pretty much the same to my eye as the one that goes through, and it continually convinces me that the web is a relatively inefficient place because it keeps sending around images that have way too much information, and that the human eye can't discern most of the information that's going around the web right now, so the web is inefficient. 50 years ago, this year, Yuri Gagarin orbited the Earth for the first time, and his view of the Earth looked a lot like that. A large gamma ray burst, that was a new type seen this year. Some people think that it's a star falling into a black hole. That's not been proven. Trying to find places on the moon where we can put astronauts in the future where there might be water. So this is a shadowgram taken over many days where there are parts of the south and north pole of the moon that are continually shadowed, and then the sun would not cause that ice to evaporate, and so there's indications that there is sufficient water on the moon, so you don't want to blast a spacecraft off carrying lots of water if you can get it when you go to the moon. So APOD does have its own search engine. It's something called Swish-E. It's free, it's open source, it has no ads. We like it because it allows us to tailor it to our needs. We have a little thumbnail when you search for something. We show, with each thumbnail, we have the full hypertext is there. And we can order it in reverse chronological order. So it does what we want. So this is the eclipsed moon recently, and this is the zodiacal light reflecting dust in our early solar system. This is the band of the Milky Way. Okay, gravity probe B determined that they're confirmed, though it's a little controversial, but it confirmed that there is something equivalent to magnetism. So electricity is to magnetism as gravity is to what? Something called gravitomagnetism, but you don't see it in everyday life. But the gravity probe B, we think, has confirmed that it's there. So there's another type of force. This is one of our most spectacular images recently, won an award. This is Aurora from up north in Iceland. So APOD is known a lot among sky enthusiasts, almost all of them know, which makes Jerry and I what I think of as micro-celebrities. So most people don't know who we are, but occasionally you run into somebody who follows our webpage and they think we're kind of special or something. So, yeah, that's cool, I guess. So there's a lot of that going around with people following blogs these days. Someone follows someone's blog, and then when you run into it, you get all nervous, like, oh, wow. Some people in the general public have heard of us, so we're not completely unknown. Running APOD, I'm mostly a professor who does research and generally hurts my academic reputation because I'm thought pretty much by people who, some people even who know my work, many people who don't know my work might think of me as a fluff boy because I must spend all this time just popularizing science and not writing real grants and publishing real papers. However, writing APOD helps keep me up with what goes on in current astronomy, and so I'm up to date, so it's easier for me to teach introductory astronomy classes. This is a space shuttle rising, the second to last launch of the space shuttle, taken from a chase plane. The last image from the Spirit rover rolling around Mars was investigating this feature here, thought to be some kind of volcanic feature near a place called Home Plate on Mars. Its other rover, Opportunity, is still rolling around Mars and sending us images. They've really done great. They've outlived how long people thought they would be. This is a picture of the space shuttle and the space station together, and how was this image taken? Is another question, and the answer to that is there was one of the escape ships came down and went back to the Kazakhstan, I think, and as it was going away, it took this image. So it's a relatively rare image of them both together. APOD has no business model. Originally, way back, when we started this with a huge bandwidth connection, we were thinking maybe we could make enough money to buy one of the Hawaiian Islands, but that didn't work out. Today, we're looking at a zero funding model. We get money from NASA. We have a NASA grant, which helps travel around and pay for things. NASA grants us the bandwidth, of course. We worry that we're going to be dropped by NASA, so we continually in the back of our minds are thinking about what we would have to do if that happened, going with a commercial alternative. We have a zero funding model. We don't really need almost anything to continue this on NASA. They don't have to give us money. They just have to keep providing us with a web host for us to keep going.
What's your average and peak outgoing bandwidth?
Well, we do about 1 million page views a day, and
Do you have any sense of the crest factor? How bunched up they are?
Well, it's pretty uniform, but there's more in the morning, and the average image size is maybe 100K. So you can figure it out from that. So lightning, here's the recent lunar eclipse. We get sent a lot of images about things like eclipses from amateurs. This is, okay, I'm wrapping up. Okay, this is a cluster of galaxies that has dark matter in it. It's interesting. So APOD is actually one of my things I'm trying to do is take APOD. It has a lot of sky enthusiasts following it and build an astronomy portal out of it. I'm calling it Starship Asterisk. It has APOD discussions. If people want to see images that are submitted to APOD and see what might be coming up, you can even vote on them sometimes. You have submitted images. I put up my courses, which I do freely on the web. Astro 101 is something called Extraordinary Concepts in Physics. We're putting together source codes. So we don't put together source codes, putting together a library of source codes because there's lots of source codes floating around astronomy and there seem to be unregulated images that we don't know what's going on. And then people write in and say, oh, I think I know what this, I think I know what that, and they battle it out. So one of my recent things is trying to build up Starship Asterisk. And this is the space shuttle rolling out for its launch tomorrow on schedule, hopefully, the last launch of the space shuttle. And that's it. I've had 2 books for APOD, and they're available in stores. So is Jerry. So thank you very much for listening.
Quick question.
Yes.
It's an astronomy picture of the day, not photo of the day. Did you
Yes.
debate that at all in the beginning, the first time you ran something that wasn't an actual photo?
No, I've never had that question. I guess we didn't debate it, but I think if we had had the wrong one or one we didn't like, we would have changed it because a picture is a more general term.
Yeah.
We've shown artists' renderings sometimes, and that's not typically a photograph. So we just went with something that seemed okay, and we didn't really debate it. Okay. Anything else? Yes.
You mentioned that you sometimes change the resolution of the pictures. I think that's what you said. Do you ever do any other editing, like crop them or change the false colors or make any other changes?
Yes, we frequently crop them because there's things on the outside we don't think are interesting. We will sometimes sharpen them, digitally sharpen them, because the eye becomes annoyed by fuzziness. And sometimes you're even better having squares that have crisp edges to the squares, pixelating it obviously, and having it fuzzy. That's my opinion. It's not scientifically backed up. Also, we compress them, right? So they have a smaller, uses less bandwidth, and so I will compress them sometimes to the point where many times a lot of the released images are like megabytes, and they can be compressed to 100 kilobytes, and you can't tell the difference. I can't tell the difference, so we frequently do that.
Question. You alluded to having an opinion about copyright of images, and I've seen some in the past where you've had to take down images or videos. How do you feel about that?
Wow, that's well, I should point out I'm not a lawyer, nor do I play one on TV. So the videos so what we've been doing is we don't typically host the videos ourselves. We link to either Yahoo or Vimeo, if that's how you pronounce it. I always see it, I never hear it. Vimeo. And what happens is there was a case recently when someone who posted to Vimeo, we thought it seemed legitimate, and it was. However, they themselves, I think they thought they had copyright. It was a show in England. The people who made the images for the show in England decided that they didn't want that, or maybe it was vice versa. But we went off the people who made the images, but then the show said, no, we're not going to allow you to do that. And so they actually pulled the Vimeo video, during the day, fortunately toward the end of the day. And so we were somewhat embarrassed. Some people think, as in the discussion section, that we should host all our own material so we don't run into that problem. We're careful whenever we send an image, we check out that we believe sincerely that we've been given permission to run that image. Am I addressing your question? Anything?
I just wanted to hear what you think.
Okay. Whether a thumbnail image needs to be copyrighted or not, we actually have been following what Google does on that. So Google search throws up thumbnails. We will go at least as large as Google is going with our thumbnails, and haven't been sued on that yet.
We have.
We're hitting time, so we should call it a wrap for the audience at large, but I know Barbara's sticking around and Noel's grabbing lunch with him if anybody wants to join in and continue conversing. Thanks.